Good morning, students. Myself, Vijay Shankar from EC Department, Civil Engineering College. Today, we are going to discuss about the encoders and the decoders. In previous class, we discussed about demultiplexer and the multiplexer. Yesterday, we completed the demultiplexer. Now you can see the encoder. Okay. The encoder. The encoder is a device whose inputs are decimal digits and are alphabetical characters, and whose outputs are the coded representation of those inputs. An encoder is a device which converts familiar numbers or symbols into coded numbers or symbols into coded format. The encoder has a 2 power n number of inputs and n number of outputs. 2 power n number of inputs and n number of outputs. As of the inputs, it is approximately the same as to the multiplexer. Multiplexer having the 2 power n number of inputs, and the encoder also having the 2 power n number of inputs. Okay, but the multiplexer the single output, but encoder n number of outputs. N number of outputs means whatever the inputs we are taking as the power, that number of outputs will get in the encoder. Okay, so 2 power n. If it is suppose there is a 4 inputs are there, 2 outputs. 8 inputs means 3 outputs. 16 inputs means it's a 4 outputs. Okay, so let us see the 4-bit encoder. 4-bit encoder means having 4 inputs: D0, D1, D2, D3, and outputs the 2 power 2. The 2 outputs only will get A0 and the A1. Okay. Now the D0 is D0. Whenever the D0 is we are taking, the outputs are 0, 0, and D1 is 0, 1, D2 is 1, 0, and D3 is 1, 1. The output will get as of the binary of the decimal values of D0, D1, D2, D3. The binary is 0, 0, 0, 1, 1, 0, 0, 2, 3 in the output side. Okay. Let the outputs having the 2 outputs, A0 and A1. Let's see the A0. A0 is where it is a high. A0 is where it is a high. D1 and the D3. And A1 you can see the where it is a high, D2 and D3. You see here. A0 in the truth table, A0 is equal to 1 and the D1, and A0 is equal to 1, that's the D3. So the A1 is equal to D2 plus D3. And similarly, A1 is equal to high at the D2 and the D3. So taking the A0 is equal to D1 and D3. Okay, D1 plus D3. So take all the 4 inputs. D0 is equal to ground because there is no any high values of A0 and A1 when there is we are taking the D0 values. D1 and the D3 for A1, and D2 and D3 is not the A0, A1, A0, and D2 and D3 is A1. Okay, the logical diagram. Similarly, if it is we can go another one, just like 4 by 1 or the 4-bit is 8 by 3 encoder, 8 by 3 encoder. So previously we've seen 4-bit encoder. Now I'm taking it is a 8-bit encoder. 8 inputs is from the D0 to D7. The D1 also there, the D2, D3, D4, D5, and the D6. So 8 to 3 encoder. So 8 means is a 2 power 3 by the 3 outputs. That is the 3 outputs are A0, A1 and A2. Okay. Here the inputs are D0, D1, D2, D3, D4, D5, D6 and the D7. These are the inputs. So for D0, the A0, A1, A2 is a 0, 0, 0. And D1 is a 0, 0, 1. And D2 is a 0, 1, 0. And D3 is a 0, 1, 1. And D4, 1, 0, 0. Now the equations are like this. The A1, let us see here. And the D5 also 1, 0, 1. And D6 1, 1, 0. And D7 1, 1, 1. Now let us see the way the A0 is high. A0 is equal to, that is one of the output, A0 is equal to, see, it is high at the D1. So D1. And next one is D3 plus D3 plus and D5 plus D7. Okay. So you're not getting the 4, D1, D3, D5 and D7 alternate. Next you can see A1 is equal. A1 is equal to D2, D3, D6 and D7. D2, D3 and D6 and the D7. Okay. And A2 is equal to, where it is a high, all the 4 is a zeros, and D4, D5, D6, D7. So D4 plus D5 plus D6 plus D7. Okay. So see here also the D0 is equal to 0. Directly connect the D0 to the ground, and remaining take as the logical diagram. Let us see the D0, D1, D2, D3, D4, D5, D6, D7. So D0 is a logical diagram I am drawing. Is a ground. D1, D2, D3 and D4, D5, D6 and the D7. Okay. Now what is the first one? The D0 is equal to D1, D3, D5, D7. So alternately. D1, D3, D5 and the D6. All it is a OR gate. Connect this to the OR gate to get the output A0. Alright. And the next one you can see the D2, D3, 6 and 7. 2, 3. 2, 3 and 6 and 7. All it is the plus values. You get the A1. Okay. And the last is a 4, 5, 6, 7. You take the 4 line D4, D5, D6 and D7. Okay. A2 is a logical diagram of 2 power n number of inputs, that is from D0 to D7, and n number of outputs, that is 3, A0 to A3. Following my dear students. Then The next topic is a decimal to the BCD encoder. Decimal to BCD encoder. The decimal value and the BCD 0 to 9, whatever we have, the binary and the BCDs both are the same. Binary and BCD. BCD means a binary coded decimal. Okay, from 10 onwards, BCD is different and the binary is different. For 10, the binary is 1010. For BCD, for 10, the BCD is each digit you have to write the binary of 4 bits. Let us see. Take the other one. See binary and the BCD. See the binary of 10. So 1010. Okay. And the BCD of 10 is a decimal value. Okay, this is a binary. And BCD of 10 is 0001 for first digit. And second digit is 0000. Is a difference. If it is 11 of binary, 11 1011 is a binary equivalence of 11. But BCD of 11 is 0001 and 0001. You can take each digit and write the binary in 4 bits. Alright. That is a difference of BCD and the binary. So now I'm taking the decimal to the BCD encoder. In this type of encoder has 10 inputs, 1 for each decimal digit and 4 outputs corresponding to the BCD code. 4 outputs. Okay, let us see how it is designed the BCD to. So see the block diagram decimal to the BCD encoder, taking only from the D0 to D9. But 10 to 15, the BCD is different. The BCD is in the 5 bits. Okay. But 0 to 9, the BCD is a 4 bits only, and the binary is also the 4 bits. Okay. But output is having only the 4 bits. So I am taking the from 10 to 15 is a logical 0. So logical 0. Let us see here. I connected the 10 to this one. The 10 to 15 is 0 values. The decimal D0, D1, D2, D3, D4, so on, 0, 1 to 9. What is a binary? D0 is a 001, 1 is a 001, and 2 is a 0010. And the last 9, you can see the 1001. 1001. Remaining we are not using because the output having only the 4. Output having only the 4, that is A0 to A3. A0 to A3. To write the 10 of BCD, the output is in the form of the BCD. It requires the 5 bits. So I'm not using the D10 to the D15. Is connected to the logic 0. I think but still to connect to the ground. Okay. So for the logical diagram, I take only the D0, D1, D2, 3, D4, and up to so on the D9. A0. You can see the A0 where it is high. D1, D3. D5, and the D7 and D9, the same thing. And A1 you can see the D2, D3, and D6, D7, D2, D3, D6, and D7. A2, D4, D5, D6, and D7. So D4, D5, D6, and D7. And A3, you can see the A3 value, D8 and the D9. D8 and D9. So the A3 having only the 2 inputs, and A2 having the 4 inputs are there. That is from D4, D5, D6, and D7. And similarly, A1 is also having the 4 inputs, D2, D3, D6, D7. And A0 having the 5 inputs. That is from the D1, D3, D5, D7, and the D9. Remaining all, it is a D0 is always a 0. And 10 to 15 is also the logic 0. Following my students. Okay. Now you go for the decoder. encoder and decoder. We already discussed about the multiplexer and the demultiplexer. The multiplexer having many inputs and single output. Whatever the many inputs are there, the 2 power n, the encoder is also having many inputs. That is a 2 power n number of inputs. The input wise, the multiplexer and the encoder, it is both are the same. Now, the demultiplexer having the reverse operation. What is a reverse demultiplexer? Means for the multiplexer, single input and many outputs. Single input and many output. Many output is a 2 power n. Selection lines is both are the same. N number of selection lines only. Even if it is a input is output and output is a input. Now, you see the decoder. Decoder is somewhat different, similar to that of demultiplexer. What is a demultiplexer? Outputs in the output side on. The outputs many outputs. Single input and many outputs. 2 power n number of outputs. Okay, so decoder is what is similar to the demultiplexer. See, a decoder is a logical circuit that converts n-bit binary code into 2 power n output lines. The reverse operation of the encoder. Encoder having 2 power n number of inputs, n number of outputs. Now it is a reverse. N number of inputs, 2 power n number of outputs. Okay, 2 power n number of output lines such that only one output line is active. Only one output line is active, is activated for each one of the possible combinations of the inputs. There is a possible combinations. If it is a 2-bit means 0, 0, 0, 1, 1, 0 and 1, 1. A 3-bit means 0, 0, 0, 2, 1, 1, 1. For every combination, the output is only activates the one line only. Okay. For each of these input combinations, only one of the output will be activated, that is a high, and all other outputs will remain inactive, means a 0. Okay, the possible combinations, whatever we have in the input side, in the output, it is activate only the one. Only one of the output will be activated high, the remaining all the outputs is a 0. Some decoders are designed the procedure active low and low output, while other outputs are remaining high. Let us see here. I'm taking the 0, 0. 0, 0 means D0 is high, the remaining all it is a zeros. The possible combinations of the inputs, the output is activate only one. The output activate only one output line, that is depends upon the inputs 0, 0. D0 is high. 0, 1. D1 is high, the remaining all it is a zeros. 1, 0, the decimal value is a 2, so D2 is high and the remaining all values is a zeros. And 1, 1, 1, 1, 1, 1, the decimal value is a 3, so D3 is high, the remaining all the values is a zeros. Okay, the truth table of the decoder. And block diagram of decoder means 2 power n number of inputs and 2 power n number of outputs. Following my dear friends. Okay. Now, you see here, I'm taking the inputs A0, A1 and the inverters also. What is a G0? So G0 is C, A0 bar and A1 bar. So G0 is high, A0 bar and A1 bar. See, I'm connected the A0 bar and the A1 bar. And D1 is A1 bar, A0. A1 bar, A0. D2 is high at these values. 1, 0. 1, 0 means 0 is A0 bar. So A0 bar is inverter from the inverter line. And A1, that is a directly line. So D2. And see the last D3, A0 and A1 both are ones. So take that from A1 and A0 as the inputs of the last AND gate to get the output is D3. Okay. Simply, the decoder means it is a logical circuit that converts n-bit binary input code. N-bit binary input code into 2 power n number of output lines, such that only one output line is activated. only one output line is activated for each one of the possible combinations of inputs. That is the definition of the decoder. Okay, to power n number of output lines such that only one output line is activated. Only one output line is activated for each one of the possible combinations of the inputs. Okay, it's a 2 to 4 decoder. Next, directly they are going, that is a 3 to 4 to 16 decoder from 2 to 3 to 8 decoder. Before that, you can see the 3 to 8 decoder. Okay, 3 to 8 decoder. So block diagram key, that's block diagram of 3 to 8 decoder. 3 to 8 decoder. 3 inputs, A0, A1 and A2. How many combinations will get here for the input side? That is 8 combinations. Okay, for all the combinations will get in the output side, only one output will activate it for all the combinations. Outputs are D0, D1, D2, D3, D4, D5 and D6 and D7. So these are the outputs we have in the 3 to 8 decoder. It's a truth table, you can see the 0, 0, 0, A0, A1 and A2. So which one is high for every possible combinations here? Input side, that is a D0, D7, D6, D5, D4, D3, D2 and D1 and the D0. The only one output is activated for the possible combinations of the input. When 0, 0, if I am taking D0 is a high, remaining all the values is a zeros one. Okay, all values is a zeros, all output values. So the next possible combination 0, 0, 1, D1 is high and the remaining all values is a zeros. Remaining all values is 0. Next is 0, 1, 0. Take the 0, 1, 0, 0, 0, 0, 0, and this value is 1 and the 0. Means diagonally you will get the output. So 1, 1 means a 3. 0, 0, 0. D3 is high and the remaining all values is the zeros. And 1, 0, 0 is nothing but the D4. 0, 0, 1, 0, 0, 0, 0. All the values. And 1, 0, 1 is a 5. 0, 0, D2, D3, and it is a D4. D4. Okay, let us see. This is also something went wrong. It is a D5, D4, D3. It's not there. Let us be the 0. Okay. And here also it's a 0. This is a 0. And the D2, D1, and the D0. Okay. Now see, is a value D5 is high and D4. These are wrong here. This is 0 and this one is 1. Now it is a 1, 0, 0, 0, 0, and 0. And 1, 1, 0, 0, 1, 0, 0, 0, 0, 0, and the zeros. Okay. And the last one, you can see the 1, 1, 1. The 1, and this one is a 0, 0, 0, 0, 0, 0, 0. So diagonally, you can see here, all the values is a 1. Okay. Now the logical diagram is G0, A0 bar and the A1 bar and A2 bar connect as a 3 input. For D1, A0, A1 bar, A2 bar. And similarly for D3, A2 bar, A1 and A0. Like that you can draw the logical diagram. Alright. Now you go for another one. The lower values, lower JNTUK, the 3 to 8 decoder, how can design the 4 to 16 decoder. So there is a 4 to 16 decoder means outputs is a 16 and inputs is a 4. But in the 3 to 8 decoder, 8 outputs and 3 inputs. So when you can use a 2 3 to 8 decoders, the outputs is same. 8 plus 8 is a 16. But 3 is already there, the input, and here also input. We can short those 3. We'll get 3 inputs. Additionally, you have to take the another input. That another input also we take as enable input. Enable input. In the multiplexer also, inside there is a inbuilt enable input. We are using that enable input when we design by using the lower values by higher values. Or here the decoders means 3 to 8 decoder. Using the 3 to 8 decoder, we are designing the 4 to 16 decoder. In that cases, we're taking enable input as of one of the additional input by using 3 to 8 decoders. To get it is a 4 to 16 decoders. Let us see the decoders with enable inputs can be connected together. Enable inputs. Let us see here. The decoders with enable inputs can be connected together to form a larger decoder. Since inside there is enable input, we are using that enable input to design the larger decoders. To obtain the 4 to 16 decoder, it requires 2 3 to 8 decoders. The most significant input bit A3 is connected to an inverter, that is E bar, on the upper decoder and directly to E on the lower decoder. And A3 is low, means 0. The upper decoder is enable and the lower decoder is a disable. Why it is enable? I am connecting the inverter there. When I am taking the 0, E bar becomes of 1. E bar becomes of 1. So with this inverter, output is a 1. From the inverter, the output is 1 and enable is a bar. Complement enable. So 1 and the complement, it becomes of the complement only. So lower decoder is disabled. Upper decoder is enabled. When higher input or the most significant input A3 is low, upper D2 to 3 to 8 decoder is enabled and the lower 3 to 8 decoder is disabled. Okay. The similar way, when A3 is high, let us see here. When A3 is high, the lower decoder is enabled and upper decoder is disabled. Why it is? When I am taking the A3 is high, directly connected to the complement enable, high and the low becomes of the low. So upper decoder is disabled. Now the lower decoder is connected with the enable input with inverter. So I am giving the A3 is 1, inverter output is a 0, and enable is a complement enable 0, and that complement it becomes of a high value. Then lower 3 to 8 decoder is a enable. Okay. When the lower 3 to 8 decoder is enabled means upper 3 to 8 decoder outputs all it is a zeros. When upper 3 to 8 decoder is enabled, the lower 3 to 8 decoder outputs all it is a zeros on. Following my dear students. The bottom decoder generates the minterms of 100 to 111, while the outputs of top decoder are all zeros. All it is a zeros. See here. The outputs of top decoder is zeros. Similarly, in the previous case, when A3 is low, the bottom decoder outputs all zeros. The bottom decoder, all it is a zeros. Let us see the block diagram. 3 to 8 decoder, 2 3 to 8 decoder I taken. Inputs are A0, A1, A2, and below 3 to 8 decoder also A0, A1 and A2, A3. All these connected as a single lines A0, A1 and A2. And outputs are D0 to D7 by upper 3 to 8 decoder, and lower 3 to 8 decoder also having the 8 outputs, but naming it as D8 to D15. But 4 to 16 decoder means it requires another input also, that is most significant bit, taken as A3 and connected to the inverter and enable input. Let us see the enable input. Okay, and this enable input is a bar. A3 is equal to 0. The output is becomes of 1. Output is becomes of 1, and the 1 is 0. So if it is not the complement value, 1, 0 becomes of inverter is 1. This is enable, and directly 0 it goes to this is a disable. And I am giving the 1 here. 1. The inverter output is a 0, and this is a disable, and 1 is directly goes to the enable here, and lower 3 to 8 decoder is the enable. Whenever if it is the disable, it will get the outputs according to the inputs of A0, A1 and A2. Okay. When the upper 3 to 8 decoder is enable, lower 3 to 8 decoder disable, and D0 to D15 is a 0 values. Okay. Now similar way, if I design another, you can see, I'm taking the another one, how we can design the 3 to 8 decoder using 2 to 4 decoders. I'm taking the lower values on. So 3 to 8 decoder. 3 to 8 decoder means it requires 3 inputs and 8 outputs. That is a D0 to D7, A0, A1 and A2 is a 3 to 8. Okay. Now I am using the 3 to 8, 2 to 4 decoders to design the 3 to 8. Okay. So let me take the 2 to 4. 2 inputs, another 2 to 4, there is a 2 inputs. I'm connecting these two as a short. You get it is A0, one is A0 and A1. Okay, 4 outputs will get here, D0, D1, D2 and D3. Okay, 4 outputs, and here also the 4 outputs, but I am giving the naming as a D4, D5, D6 and the D7. Okay, so totally you get the 8 outputs. Inputs are how many here? 3 to 8, it requires 3, but we have only the 2 only. So another input I am taking, connecting as inverter and give the enable input. It is uncomplement enable input, let us see. And here also I am connecting to the enable input, that is uncomplement A3. Okay. When I am giving A3, see the A3, not the A3, it is the A2, my dear students. A2, A1 and A0. Okay. See, A2 is a 0, 0, 0, 0 for 4 combinations. When A1, 0, 0, 0, 1, 1, 0 and 1, 1 conditions. So until these 2 inputs here, when I am selecting the 0, 0 here, the input given the 0, 0, D0 is high, 0, 1, D1 is high, 1, 0, D2 is high, 1, 1 is a D3 is high. At this case, A2 is a 0 means A2 is 0, directly will get the enable input is a 0. Okay. When A2 is 0, the lower 2 to 4 decoder is disabled. A2 is 0 with this inverter, the value is 1 here, and upper 2 to 4 decoder is enabled. Okay, we get here the D0 high, D1 is high, and D2 is high, and D3 is high. The remaining all it is outputs is a 0 zone. Now when I am selecting the A2 is equal to 1 and A1 1 0 1 1 1 0 and 1 with 1 1. Okay, in this case this is a disable. Upper 2 to 4 decoder is a disable because of 1 inverter output is a 0 here. Upper 2 to 4 decoder is a disable. Now the 2 to 4 decoder, lower 2 to 4 decoder is enabled. According to these two inputs, we'll get the outputs. Now here the D4 is high, remaining all it is a zeros. D5 is high, remaining all it is a zeros. And D6 is high, remaining all it is a zeros. And D7 is high, and the remaining all it is a zeros. Like this, we can design the lower decoders and upper. Using the lower decoders, we can design the upper decoders. Following my students. So with this, the completion of the decoders and the encoders. Once again, I will explain what is an encoder means. Encoder having 2 power n number of inputs and n number of outputs. Okay, decoder means n number of inputs, 2 power n number of outputs. As of input values, multiplexer is similar to the encoder and a demultiplexer is similar to the decoder. Why it is? The multiplexer also 2 power n number of inputs. Encoder also having the 2 power n number of inputs. And a demultiplexer having 2 power n number of inputs. Not the inputs, outputs. And decoder also having the 2 power n number of outputs. Following my students. Like this, the multiplexer is related to the encoder and demultiplexer is related to the decoder. Understood? Only for the input sides, input only. But actually the multiplexer and demultiplexer having a single output for the multiplexer and a single input for the demultiplexer. 7-segment decoder or the BCD 7-segment decoder we can call it as. So this type of decoders accepts the BCD code. Okay. The input is a BCD code, so it is also called as a BCD 7-segment decoder or 7-segment decoder, and produces the outputs to analyze 7-segment display devices in order to produce a decimal readout. Decimal readout, whatever they are giving here, binary value. The binary value is 0 0 0 0 means that the output side it displays the decimal value of that binary. If it is a 0 0 0 1 means it displays the 1. That is a binary of 1 is a 0 0 0 1, and the output side it displays the decimal value. Okay. So this type of decoders accepts the BCD code and produces outputs to analyze 7-segment display devices in order to produce a decimal readout. Each segment is made up of a material that emits light when the current is passes through it. Okay, let us see here. There is a one light is there. Totally it is represented of 8. A is on and off is a light, and B, C, D, E, F, and the G. Okay, it emits a light when the current is passes through it. The most commonly used materials include the LEDs. Okay, the totally how many number of LEDs are there here? 1, 2, 3, 4, 5, 6, and the 7 total. A, B, C, D, E, F, and the G. Okay. See now, there's a block diagram of the 7-segment decoder or the BCD 7-segment decoder with the 4 inputs A0, A1, A2, and A3, and outputs are the 7 outputs. That is a small a, small b, small c, d, e, f, and the g. So g is also the small g only, my dear students. See the truth table, the decimal value of the 0, and the BCD input also. You can see the BCD input is a 0, 0, 0, 0. A3, A2, A1, A0. See, in the 7-segment output code here, it all the high for A, B, C, D, E, and F, and G is a 0. Means the LEDs of A, B, C, D, E, F is on, and only the G is a 0. Means it displays the binary of the 0, 0, 0 in the decimal value 0. Okay, let us see here. If I am taking that is A, B, C, D, E, F is the value of the 0. So of the Z, following my dear students, the Z is a 0 here. Then for the second value, you can see the 1. The 1 is a decimal digit. It represents, it is in the A and the B is on, the remaining all the 5, C, D, E, F is a F, and G is also off. The binary is a 0, 0, 0, 1. I can see the A is 0, D is 0, E is 0, F is 0, and the Z is 0. It's only the B and C is on. B and C is on. Let's see here. 1 is like this. So here the A, B, C, this one is a D, E, F. So if all these A, B, C, D, E, F is on of all the LEDs, it shows is a decimal of 0. Now the A and B, if A and B is on, now it shows a 1. The remaining is C, D, E, F, and the G. Not the, this is not the A, is a B, my dear students. B and C. A is off, E is off, F is off, and D is off, and G is also off. All right. The next one is, now if I'm taking the 2, decimal value of 2, the binary is 0, 0, 1, 0. As of A0 is 0, A1 is 1, and A2 is a 2, and A3 is a 3. Now in the output side, the 7-segment code A, B, C, D to the G value, which one is a high? Only the 2 is off. That is A, B, C, C is off, and D is on, E, F is off. So C and F only is off, but here whatever in this it is wrong, my dear students. The C is 0, okay, and F is 0. Not E is not the 0 here. E is not the 0. E is also the 1. Let us see. I will show that one. Now A is on, B is on, C is on, not the C. G is on, and E is on, and the D is on. Okay. Only it is off of C and the F. A is on, B, the C is off, D, E, and F is off, and the G is on to get the 2. There is a 2 value. In the truth table, there is some wrong is there. In the regular class also, I told that the C is 0 and the F is 0, not the E is a 0. Change is 1 is a 1, my dear students. Okay, change is as a 1. Following, my dear. Now coming to the 3. How we can get the 3 in the output side by taking of the BCD inputs of 0, 0, 1, 1. 0, 0, 1, 1 means is a line of EF and is a line of E. Means E and F is a zeros. You see here, E and F is a zeros here. Let us see that also. To get the 3, A is on, B is on, and C is on, and D is on, and the G is on. So A, B, C, D, E is off, and F is also off. E, F, G is on. So only E and F are the zeros. E and F are the zeros in the, to get it is a 3 in the output side. Okay. E and F. Only here the 2 is wrong. Change that E as a 1 when take the BCD input is 0, 0, 1, 0. And coming to the 4 is a decimal value, and in the BCD 7 segment it is shown like this, and the BCD binary is a 0, 1, 0, 0. So which one is on and which one is off? Let us see here, the A is off. So A is off, BC is on, and E is off, and D is off, and E is off. A, D, and E is off. The remaining all it is on. Let us see that also. To get it is a 4. I am taking F is on, G is on, okay, B is on, and the C. B and the C. The remaining E, D, E, D, and the A. So A, D, E is the off to get as a 4 to display in the output side. Okay. Now coming to the 5th one, see the 5 here. The binary of 5 is a 0, 1, 0, 1. So which one is off? The B and the E. B and E is off. So see here the B is a 0 and E is a 0. The remaining all it is on. To get it is a 5 in the output side, the BCD. Let us see as a 5. I'm taking the 5. A is on, and F is on, and G is on, and the C is on, and also the D. So only the 2 is off here. That is a B and E. B and E is off. The remaining all it is on. Then it shows in the output side as a 5. Next you can go for the 6 like this. Directly I am taking here the 6. I would get the 6. So suppose if I am writing this is 6 like this, it is also 6. But otherwise you can take like this also the 6. Okay. So A is on, B is off, C, D, E, F, and the G. Okay, only to get the 6, B is off. Now in the truth table also, you can see the truth table. For 6, the B is off. For 6, the B is off, my dear students. And coming to the 7, seven means like this. The 7 is like this. Okay, only A, B, C is on. Remaining D, E, F, and the G is on. The off, not the on, off. In the truth table also, we'll get 7, 0, 1, 1, 1. The 4 is off. Is A, B, C is on. A, B, C is on means it is a 1. The remaining D, E, F, G is a zeros, my dear students. And 8 means total it is on. 8. How it look like is 8. A is on, the B is on, the C is on, the D is on, and E is on, F is on, and the G is on. Okay, A, B, C, D, E, F, and the G. To display the 8, all LEDs from A to G is on. Okay. And coming to the 9 here, the 9 only E is off. E is off, not the E. D is off. Okay. Not the E. It is also wrong, my dear students here. One thing is a 2, 1 is a 0 is there, the E. It is a wrong. You have to replace that is a 0 by 1 here. And 9, you can see in the 9, it looks like this. 9 means like this. It's a 9. Okay. Or otherwise, a 9 also like this. Means it is on of A, B, C, D, E is off, and F and the G. So only the E is off. Now see, it is right or wrong in the truth table. Only E is off. Okay. It is not the E. It is 0 in the D. Change it is D is 1 and E is 0. There is a 2 wrongs in this truth table. When to display the 2, additionally that is a E is 0 here. You change that E is 1. Alright, only the B and the F is the zeros. And to display the 9 also, only the E is 0, but here D shows the zeros and E is 1, interchange is 1, D is 1 and E is zeros. According to that, you can design the BCD 7 segment or 7 segment decoder. See why it is a BCD, the 4-bit BCD and the 4-bit binary is the same as from the 0 to 9. And for the 10, the BCD of 10, it requires a 5 bits. BCD of 10 is requires a 5 bits because each digit you have to write it as a 4 bits binary. 10 means one digit is having the 0, 0, 0, 1. And 0 is, again, you can write the 4 bits 0, 0, 0, 0. Means in the left hand side, 3 zeros, you can remove that 1. So totally 4 zeros in the right hand side. So totally the 5 bits are required for the 10 in BCD form. In BCD form, my dear students. Okay. So the remaining whatever we have in the 4-bit 10 to 15. 10 to 15 is a don't case for all the cases. For all the cases, so you have to write out the minterms Boolean functions as of A to the G, only wherever it is a high, that only can take as a minterms, and a remaining from 10 to 15, all it is a don't case only. Let's see the A. So where it is a is high. Let's see here, the where is a high. 0 at 1 and 4 at the 0. Remaining all it is a minterms. Means 1, 0, 2, 3, 5, 6, 7, 8, 9 are the minterms. So only we are not taking the 1 and the 4 because it is those are the zeros. And from 10 to 15 is a don't case. Why we are taking the don't case from 10 to 15 in the 4-bit binary? Have to represent the 0 to the 15. Here to design the BCD decoder or the BCD 7 segment decoder, we use only the 0 to 9. We are not using the 10 to 15 because the input is a BCD. Input is a BCD. From 10 to it is a 5 bits required. So I taken only the up to the 9, the remaining 10 to 15 you can consider it as a don't case. Alright. And B, what are the minterms of B? 0, 1, 2, 3, 4, and 5 and 6 we are not taking because those are the zeros, and 7, 8, 9. You see here, 0, 1, 2, 3, 4. We are not taking the 5 and 6 because those are the zeros, and 7, 8, 9. The remaining the don't case, 10 to 15. Okay. And C here, C. C is a 0 at the 2. And remaining all the minterms. So 0, 1, there is no any 2 because it is a 0. 3, 4, 5, 6, 7, 8, 9, and the don't case are 10 to 15. And D, so here the D is 1, 0, 1, 1, 0, 1, 1, 0, 1. This is not the 0, my dear students. This is also 1 because it is a 9. The E is a 0, not the D is a 0. Okay. So what are the minterms? 0, 2, 3, 5, 6, 8, and 9 also. And 8 and 9 also. See in the D, 0, 2 is here. 0, 2, 3, 0, 2, 3. 5, 6, here the 5, 6, and 8, 9 also. Okay, in the truth table only we represent the 0, but here it taken the 9 is a min term. Here it is a right term. 0, 2, 3, 5, 6, 8, 9. Okay, 0, 2, 3, 5, 6, 8, and 9 also. Okay, and the remaining the min terms only, not the min terms, don't case 10 to 15. And coming to the E value. So E here I told that it is a for to display the E is not the 0, it is a 1. E is not the 0, it is a 1. So what are the min terms to get here? 0, 2 also. 0, 2, and then 6, 8, 9. 0, 2, 6, 8, 9. 0, 2, 6, 8, 9. Why it is not the 9? It is a 1. It is a 0 because in the 9 it is a 0 value. D is 1 and the 0. So only we have the min terms is a 0, 2, 6, 8 only. 0, 2, 6, 8. 0, 2 is 1 and 6 is 1 and the 8. It is not the 1, my dear students. It is a 0. So the min terms what we take here, it is a right only. 0, 2, 6, 8. The remaining 10 to 15 is a don't care only. Okay. Coming to the F values, 0 is a min term, and 4, 5, 6, 8, 9. 0, 4, 5, 6, 8, 9 is a min terms, and 10 to 15 is a don't case. And to get this G, you see here this G, 2, 3, 4, 5, 6, 8, 9. 2, 3, 4, 5, 6, 8, 9. What are the min terms we wrote here? The min terms is a right, but in the truth table only there is a wrong is there. That wrong is add the 2, E is not the 0, it is a 1. And at the 9, D is not the 0, it is a 1. And E is the 0. Only you have to change these 3, interchange these 0 and 1, and change the 0 as 1 here. Then whatever the min terms we taken here, the A to G is absolutely the right. Using that min terms and the don't case, you have to go for finding out the Boolean function by using these min terms. How to find out the Boolean function to design the BCD 7 segment decoder. Okay, because it's a 4 variable K map, we have to use a 4 variable K map to find the A Boolean expression, B, C, D, E, F, and the G also. Okay. Now I'm taking the A, 0, 2, 3, 5, 6, 7, 8, 9 of the min terms. Let us see here. A1, A0, I'm taking the horizontally. A2 and A3 is in the vertical. A0, A1, A2, and A3. A0 is a LSB bit and A3 is a MSB bit, least significant and the most significant. Means the most significant is always in the left hand side, and the right hand side is the least significant. So A3, A2, A1, and A0 from left hand side to the right hand side. Okay, so I'm taking LSB bits A0, A1 in the horizontally, and MSB bits A3 and A2 in the vertical. 0, 0, 0, 1, 1, 1, and 1, 0 is the gray code. The gray code only we are using in the K-map to reduce the Boolean expression or to give the minimum number of literals. Alright. See, it's a 0, 0, 0, 0 means it is a 0 box. 0, 0, 0, 0, 1. You can take always vertical values is MSB bits. 0, 0, 0, 1 is a 1, and 0, 0, 1, 1 is a 2, and 0, 0, 1, 0 is a 3. So like that you will get the 0, 1, 2, 3. So not the 2, my dear students. So this is a 3 and this is a 2. In the box also there is a representation is wrong here. So 0, 0, 0 is a 0, 0, 0, 0, 1 is a 1, and 0, 0, 1, 1 is a 3 here. This is the 3 box. And this is a 2 box. 0, 0, 1, 0 is a 2. This is also 4, 5, 6, 7. These are right. 8, 9, 10, 11. 12, 13, 14, and the 15. Okay, you change this as a 3 and this one is a 2. What are the min terms here? The minterms are 0, 2, 3. This is 0, 2, 3, okay. And 5, 6, 7, 8. So 5, 6, 7, 8 are the minterms, and 9 also. So whatever you represented here, the same. There is no any wrong, but the box number is a change is there. Even it is a 2 and the 3 interchange that one. From 10 to 15 is a don't case. From 10 to 15 is a don't care. Now let us see the first of all, is there any 16 box combination is there or not? There is no any 16 box combination because 1 and 4 is not covered here. The remaining is a minterms and the don't case are there. Then after you can see the 8 box combination. Okay, there is 8 box combination is there. With vertically you can see it covers 6, 7, 2, 3 as a minterms and including the don't case of 14, 15 and the 11 and 10. So take it as a 8 box combination, vertically 8 box combination here. Then after 8, 9 minterms are there. Using these 8, 9 minterms, under 8 box combination we have with don't case of 10 to 15, 10, 11, 12, 13, 14 and 15. So 8, 9 is also covered. So 2, 3, 6, 7, 8, 9 is covered and remaining is a 0 and 5. Only the minterms we have, the remaining is a 0 and 5. Including the don't case is also covered. So to get it is a 5, the 5, and you can see that the 5 and 7 here they are using, it is a two box combination. It is not the 2 box combination, my dear students, it is a 4 box combination. Since there is a 13 and 14, 13 and 15 is there in the don't case, you can use the maximum box combination with don't case. Don't go for the 5 and 7 only, the 2 box. You can use that, it is a 5, 7, 13 and 15 is a 4 box combination. To cover the 5 minterm, you can use already covered 7, already covered 13 and 15 the don't case. Okay, it is not the 2 box combination, it is a 4 box combination. After completing of the 5 and 0 is only the minterm is remained. So for that 0, you can see the corner bits. When you can fold the corner bits, you'll get the adjacent sides of 0, 2, 8 and 10. That is a 2 box, my dear students. 0, 2, 8 and 9. So when we are folding that one, these 4 are adjacent boxes. To get it is a 4 box combination. Okay. Now again I will show that if any confusion, see I'm taking the 4 box 4 variable K map, 4 variable K map of I'm taking the A1 and A0. These are the LSB bits, and A3 and A2 are MSB bits. 0, 0, 0, 1, 1, 1, and 1, 0, and here also 0, 0, 0, 1, 1, 1, and the 1, 0. Okay. So always you can see that from the MSB bit to the LSB bit. A3, A2, A1, A0 is a 0, and this is a 1, and this is a 2, and this is a 3. Okay. There is a wrong of keeping the numbers of the box is a 2 and 3 there. There is a 4, 5, 7, and the 6. And this one is a 8, 9, 11, and 10. 12, 13, and 15, and the 14. So this is the way you have to use the box numbers. Okay. Now what are the minterms here? 0, 2, 3, 5, 6, 7, 5, 6, 7, 8, 9, 0, 2, 3. Okay. 0, 2, 3, 0, 2, 3, 5, 6, 7, 5, 6, 7, 8, 9 also. 8 and the 9. These are only the minterms. Okay. Otherwise, if you have any confusion, the minterms are, these are the minterms. And the don't case, I'm using the don't case here from 10 to so 10, 11, 12, 13, 14, and the 15. These are all the don't case. Now this is a way, there is no any 16 box combinations. We have only the 8 box combination. Let us see the first 8 box combination of this one. So it covers of 2, 3, 7, 6. Second 8 box combination. The second 8 box combination is here. This one is the second 8 box combination. Okay. So remaining only the 2 minterms, so 0 and 5. So for this 5, to cover this 5, I am using the 4 box combination, including the 13 and 15, my dear students, including the 13 and 15. If it is a 5, if it is having the 1 is also there, there is another 8 box combination, you get like this. Okay. So for 0 is a remaining, for last corner bits, the corner bits here is a 4 box combination. So 2 8 box combinations and 2 4 box combinations. What is the expression we'll get here? The function of A3, A2, A1 and A0 is equal to. First I am writing this one. This is the first 8 box combination, and this one is second 8 box combination. For the first 8 box combination, you can see there is a covered of totally A3 and A2. So it becomes of 1. And remaining here, the A1, A0 is 1, 1 here, and A1 and A0 is 1, 0. So the A0 is changes from 1 to 0. So it is ignored, and we have only the A1, A1, A1. Why I am writing that A1? Because it is a value is 1. If it is a 0 means A1 bar plus the second, you can see the 8 box combination is horizontally there is 8 box combination is there. So A0 and A1 is a value is 1, and A3 and A2, now you can see the correspondingly 1, 1 and 1, 0. A3, there is no change in the A3. A2 is changes from 1 to 0. So I am ignoring the A2, taking only the A3. A3 plus, so you'll get the reduce of the literals also. When 8 box combination means we'll get only 1 literal. 4 box means 2 literals. 2 box means 4 literals will get. Single box, or not the 4 box, it is a 3 literals. And single box means 4 literals. Gradually it is reduces. Single box 4, 2 box is 3, and 4 box is 2, 8 box is 1. And if there is a 16 box means we'll get the value of 1. Now I'm taking these 4 box combination. These are 4 box combination, take it as a 3, and corner bits is a 4. For this 4 box combination, you can see correspondingly 0, 1, 1, 1, 0, 1, 1, 1. A1 is changes. You see here. A1 is a 0 here and A1 is a 1 here. So A1 is ignored. Only I am taking the A0. So A0. And corresponding, you can see here, A3 is changes from 0 to 1 and A2 is not changes, is a 1 only. So A2 and the A0. Why I am writing the A2 from left hand side means these are the MSB bits. A2 and A0 plus another 4 box combination is there, the corner bits. See the corner bits is 0, 0, 1, 0. 0, 0, 1, 0 means A1 is changes from 0 to 1 here. So A1 is ignored and A0 is a 0. A0 is a 0 means A0 bar. A0 bar. And correspondingly, you can see the vertical A3 is a 0 and A2 is a 0. A3 is 1 and A2 is a 0. A3 is changes from 0 to 1 here. A3 is changes from 0 to 1 and A2 is the 0. So 0 means A2 bar. A2 bar. Okay. So you'll get the final expression, the minimum number of literals in the each term, A1, A3, A2, A0 plus A2 bar and A0 bar. These are A2 bar, my dear students. A2 bar. Okay. But see what I already shared to you, the material. In this material, the K-map, it shows A1, A3, A2 bar and A0 bar plus these are 4-box combination. If this is a 4-box combination here, if the 4-box combination means A0 and A2 only, there is no any A3. It change is 1, there is no any A3. Remove that A3. If any maximum box combination is there, you go for the maximum box combination only. Okay. Don't use the minimum box combination. So whenever you are going with the minimum box combination, means it increases the number of literals. By using the K-map, you have to reduce the number of literals also. Number of literals. 4-box combination will get the 2. And 8-box combination, it is a 1 literal. And 16-box combination means it is a value of 1. And single box combination means the maximum how many number of variables you can take as a K-map, that will get as a total variables. That should manage students. There is a wrong is there, that is there is no any A3 bar. When we take it is a 4-box combination. This is a 4-box combination. You can take these totally the 4-box combination. 13, 15 and the 5 and 7. Coming to the B. So what is a B? In terms of 0, 1, 2, 3, 4, 7 and 8, 9. 0, 1, 2, 3, 4, 7 and 8, 9. 4, 7, 8 and 9. Okay. Whatever the min terms is there given, it replaces the same. And the don't case of the 10. Don't case of 10, 11, 12, 13, 14 and the 15. Okay. You can see here, first of all, you can always observe only the min terms. If there is a min terms is covered, you leave it the don't case. Don't see this 8-box combination here. When you go for this 8-box combination, and 8 and 9 only is covered. So when I take this 0, 1, 2, 3 and 8, 9, 10, 11 as 8-box combination, it covers the 0, 1, 2, 3, 8, 9, the min terms. Okay. Let us see. I'll go for the another one, the 4-variable K-map. A1, A0, A3 and A2. Okay, A3, A2, A1 and order. This order. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1 and 1, 0. So 0, 1, 3, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15 and the 14. So these are the min terms. 10, 11, 12, 13, 14, 15 is the min terms. What is the min terms? Don't case that is. What are the min terms here? Min terms is 0, 1, 2, 3, 0, 1, 2, 3, 4, 7, 8, 9. 0, 1, 2, 3, 0, 1, 2, 3, 4, 7, 8, 9. Okay, 7, 8, 9. Is it right? 7, 8, 9. 4, 7, 8, 9. Okay. So if you go for this 8, 9 is covered with a 4 8-box combination, but you see only the first of all it is covered the min terms. I'm going for the 8-box combination like this. So it covers the 0, 1, 2, 3, 8, 9 also. And what is the remaining here? The 4 and 5 is only the remaining. So I take this 1 4-box combination, and this is another 4-box combination. So leave it at the 13 and the 14 of the don't case. So for 8-box combination, A0 and A1 is a zeros, not the 0 is ignored, and the 0, 0, 1, 0, A2 bar. That is 8-box combination A2 bar plus, and for this 4-box combination, A3 and A2 is a 1 and A0